Okay, so this is a 9-volt battery. This is an LED, which probably takes about 2 volts. On a 9-volt battery, this is the positive lead, and this is the ground lead. Let's see if we can burn this out. Yep, I think it already burnt out. Notice that it doesn't light up at all anymore. And if cameras had a sense of smell, I would let you smell it, because burnt out LEDs stink. So, anyway, please don't try this in class, because even though we have a lot of LEDs, and they're relatively inexpensive, we don't really want to blow out a lot of them. So, if you're ever going to use a 9-volt battery to power an LED, you are going to use something called a resistor. This is a resistor. They basically all look the same. Sometimes the wire is thicker on some of them, but they all have this ceramic bead in the middle of it, and that's the thing. The bead is the one with the stripes on it, and the stripes indicate what strength the resistor is. So this is a 330 ohm resistor. So we're going to use the breadboard again. It will be good practice on how to connect stuff. So I'm going to put the positive end of the battery into the positive channel, and the negative end of the battery into the negative channel. Okay. Then I'm going to take a wire. I like to color code my wires. You don't have to. You can use any color you want, but I think especially when you're starting out, it makes more sense to use colors that we associate with positive and negative. So red's a positive, and blacks, blues could be for ground or negative. So I'm going to take that power from the positive channel into any place on the breadboard. Now, we don't want to go straight into the LED, because that's the equivalent of what I just did when I held it on top and it burns it out. So instead of putting the LED next, we're going to take the resistor. Now resistors don't have positive and negative ends, so it doesn't matter which end you put where. Oh well, it matters where you put them, but it doesn't matter whether you put this side or this side. They're both the same. Okay, so I'm going to take the resistor and put it into the same column where the battery is, and then to any other column. And I could have done the light first. I think actually I'll do that in a second, but I think our diagram showed the battery going into the LED. But anyway, I have this resistor in the same column as I have the power from the battery. I'm now going to take an LED. I think I'll use yellow this time. I'm going to take the positive leg of the LED and put it in the other leg of that resistor. I'm having a hard time pushing them in. And then the short leg can go to any other hole. So it looks like it's hard to see, but we have red, the battery power going onto here, which is in the same column as the one leg of the resistor. The other leg of the resistor goes to a different row column, and the long leg of the LED goes into the same row as that other leg of the resistor. So now we have the short end of the resistor not going anywhere, which means we have an incomplete circuit, and the circuit's not going to be complete until we take the short leg of the LED back to ground. Now I have a full circuit, my light's on. And it's not going to get burnt out because this little guy is protecting us, because what it does is it takes that 9 volt and it slows down the current so that the circuit is at a voltage that the LED can handle. And we can still do the same thing as before. If I want to plug in another light, I can just plug it into the same 2 columns and I'll get another light on. So we can keep doing that. Okay.